Okay, so there's 5 questions, and again, if I were looking at this and I were looking for low-hanging fruit, and again, what I mean by that, a confidence builder, something you could grab, do quickly, and move on. I'm going to say probably 4 looks like the easiest problem in that set. All right, and then after 4, I'd probably go to 5. Then after 5, I'd probably go to 2. 1 and 3 is a toss-up. We'll get there. All right, I need a confidence builder. I'm going to do number 4 first. And the way to do that is the way you were taught probably in an algebra class or possibly pre-calc, and that was to compare this to 0. It's a rational problem. So I write down 0, and you get 2x plus 1 plus 5 over x plus 4. Now I got to get one term. I'm going to add this together now. That would be x plus 4 is a common denominator. And then you get 2x plus 1 times x plus 4 plus 5. I'm going to still work, I'm going to still work on this. X plus 4. And you get 2x squared. Let's see, plus 8x plus 1x is plus 9x plus 4 plus 5. I'm hoping it's going to work out really nicely. I need a confidence builder. I'm going to factor the bottom. And the top I know is 4 and 5 is 9, so let me try to factor this. And I'm hoping it's going to work without using a quadratic formula. Looks like 3 and 3. And plus plus. Let's see if that works out. You get 2x squared. 2x times 3 is 6x. 6x plus 3 is 9x. And 3 times 3 is 9. Works beautifully. So what do I do now? I put a number line down. And on that number line, I would list the zeros of the top and of the bottom. And the 0 on the bottom is minus 4. And the 0 on the top would be minus 3. And the other 0 on top would be minus 3 halves. Then your teacher told you to take test values on the intervals. And I've got, 1, 2, 3, 4 intervals. We'll take test values. I'm going to say a good value after minus 3 halves would be 0. That's a test point. Plug it in. And again, what I mean by plugging it in, you're plugging it in here. This is where the analysis becomes incredibly easy to do. So if you plug in 0, what do you get? Positive, positive, positive. Everything's positive. Are positive numbers greater than 0? Of course they are. So this all gets shaded in. I want to point out minus 3 halves also gets shaded in because it produces a 0. All right, now I'm going to go between minus 3 and minus 3 halves. I guess a good test point there would be minus 2. If you plug it in, what do you get? Well, on top you get negative, positive, positive. So overall it's negative. I would not shade that in because that's not greater than 0. Now, does minus 3 get shaded in? Yes, because it equals 0 at minus 3. Now I got that shaded in now. I'm going between minus 4 and minus 3, and I'm going to say minus 3.5. And I need to plug it into that green highlighted area, and that would give me a negative number, and a positive number on bottom. So overall, it's positive. This was an sign analysis. All right, that's done. I'm going to go below minus 4, like minus 5, plug it in. You get negative times a negative, which is positive, divide by a negative, which is a negative. So I have my answer now. And my answer is, I'm going to write it down for you. So for number 4, my answer is minus 4, comma, minus 3, right bracket, union, left bracket, minus 3 halves, going off to infinity. All right, I got work and an answer. I want to point out, I want to look, and that's number 4, right? And I want to make sure you know what I'm doing. I'm looking at number 4. And I'm seeing the answer over here. All right, let's go back. And I feel pretty good about that. That's a confidence builder. So number 4 is done. What I'm going to do now, I'm going to erase. Right, remember, this is recorded. You can always return to it and look at the beginning if you need to. Now again, when I do this over here, this is my chicken scratch, and I put work down. I want to put out the work that I'm putting down is typed up for you. All right, not the chicken scratch. Right, this one says, the consecutive angles of a trapezoid. Well, one thing you may want to remind yourself what a typical trapezoid might look like, this over here. I'm going to put this over here, maybe something like this over here, right, trapezoid. I'm not doing a great job at drawing a picture out. But, if you know the sum of the angles, that's fine. But I'm going to say, let's say I don't know the sum of the angles. I'm going to put this down, which is probably what your teachers told you to do in grade school, right? And I'm going to write some angles down for you. I'm going to say this is the angle x, and this is the angle 90 degrees minus x. This is the angle 90. This is 90. This is the angle y. And this angle over here would be 90 degrees, sorry about that, minus y. I'm going to add all the angles together. And I'll tell you what I mean by angles. They're talking about these angles here. And there's 4 of them. I'll write this down just to make sure you understand the sum of the angles. X plus 90 degrees minus x. I did this one. I'm almost doing this one over here, but I have to add another 90 degrees onto that, right? So I just did this one, and I did this one. Now I want to do this one. And what's that going to be? Y plus 90 degrees. And what's this one over here? It's going to be plus 90 degrees minus y degrees. Well, let's add this together. What's nice about it? A lot of things disappear. And I'm looking at it, and the sum of that would be, there would be 490, so the sum of the interior angles over there is 360 degrees. All right? Now, let's say you knew that. You would not waste your time with what I've just done then. You wouldn't do it. All right? What does it say? It says the smallest angle is 75 degrees, but they say it forms an arithmetic sequence. So what does that mean? 75 degrees would be the smallest angle. The next angle would be 75 degrees plus some common difference d. That's the next angle. What's the next one going to be? It's arithmetic. So it's 75 degrees plus 2d. And what's the next one going to be? 75 degrees plus 3d. What's that equal? That equals 360 degrees. I'm adding all 4 angles together. Well, let's do it. You get 360 degrees. I'm going to be adding the 75s together first. And that's going to be 300 degrees. And then I'm going to add the d's together, and there's going to be what? 6 d's, right? I'm going to try to figure out d. We'll get to that question later, by the way. This is 60 degrees equals 6d. And what do I know d is now? D is actually 10 degrees. What's their question now? Their question is, what's the largest angle? Well, this would be the largest angle. So it's going to be 75 degrees plus 3 d's. Well, if d is 10, that's going to be 30 degrees. So what's the largest angle going to be? 105 degrees. What I want to do is I want to go, again, this is my chicken scratch. I'm going to go to the answer key, and I want to see if I got the right answer. Yep, 105 degrees, and they got the work down over there, all right? Now, again, for some students, the work is more than sufficient. Like if this were a competitive exam, that would be the work for a competitive exam. Someone would look at that and say, yeah, they knew what they were doing, they answered the question, all right? Now, some people need me to talk through it. If you need me to talk through it, I'll talk through the problems. That's all I'm doing. But these are an answer key, and they're given to you for a reason. So I'm going to kind of look through the problem, and I'm looking through the set, and I got 2 confidence builders done already, all right? So I did 2 problems, and I'm kind of searching around for another easy one to do. And this is a typical strategy some students follow. Unfortunately, what happens to a lot of students, they pick a wrong problem, and they get stuck, and they can't get anything right in the problem. But I'm going to say number 2 doesn't look bad. And so I'm going to remind you what maybe your pre-calculus teachers taught you or your trig teachers taught you. They taught you, you put a parent curve down. I'll write this over here. Sine of theta is equal to, well, that's going to equal to 0, right? And the question becomes is, when does it equal 0? They told you to draw a picture of the sine function. And once you start to realize the sine function becomes 0 at many places, but it keeps hitting at a period. So I'm going to say theta would have to be equal. It appears to be hitting every pi units. So I'm going to put down pi n, with the understanding that n is any old integer. All right, any integer. 0, 1, 2, -1, -2, yada, yada, yada. So what I'm going to do is, again, I haven't even looked at the question yet, but I want to see if I can solve this thing here. And what do I know about this over here? Well, this has got to be that. So I'll write this down now. This is 25x over 3 minus pi over 6 is equal to pi n. Again, the understanding that n is any old integer. I would probably multiply both sides by 6. And if you did that, you would get 50x. Again, I'm multiplying by 6. 3 goes in 6 two times. 2 times 25 is 50. Minus pi. And let's see what you get. If I multiply by 6, you get 6 pi n, right? And let's just keep moving forward. I'm going to try to solve for x now. This is 50x equals pi plus 6 pi n, right? I'm going to divide by 50. And now I know what x is. I don't think that's our question, though. Again, n can be any integer. What's our question is? Determine the number of solutions where x is between those two numbers. Well, I got to write that down now. So the x is between those two numbers. Let's be careful about this, all right? Whoops, sorry about that. And pi plus 6 pi n over 50 is less than or equal to 2 pi. Let me just repeat what we're doing over here. We're kind of reading. We don't know what the question is yet. I mean, actually, you do know the question. I'm just saying that you may forget the question. I'm going to multiply both sides by 50. Right, what would you get? 0 pi plus 6 pi n less than or equal to, let's see, that would be 100 pi, right? Now, what's the question is, I got to get, how many n's are going to be, and you can start counting them if you want, but I hope you realize that n cannot be a negative integer. And the reason being that would be a negative numbers, and negative numbers are not greater than 0. But it could be 0. So I'm gonna write down the possible n's now. So the possible n's are going to be from this set over here: 0, 1, 2. Right? Again, you can keep going on, but I got to be really concerned about this over here. So what I want to do is I want to see what the upper limit of n is. This would be pi plus 6 pi n, and I want it to be less than or equal to 100 pi. So I'm going to try to figure out the n for that. I'll just write equal to that. I want to see what's the biggest n could be. So you get 6 pi n equals 99 pi, and then I'd probably divide by by pi. You get 6n equals 99. I'd probably divide by 3 now. 2n equals, I'm dividing by 3, by the way, 33. All right? So then I'm looking at that. And I'm going to say the most n could be, again, I realize that some people want to say it's 33 divided by 2, which is 16 and a half. But you can't use 16 if it's n. So what's the most it could be? 16. If I did 17, it'd be way too big. All right? What's their question, though? Let's go back and read it. Determine the number of solutions, and it all has to do with n. How many are there? Well, I hope you don't have to count with your fingers, but there's going to be 17 of them. Let's take a look at our k. And again, I want to look at it. That's number 2 now, right? Oops, I got one too fast there, didn't I? Oh, number 2's right here. Sorry about that. Yeah, 17. We got him. All right, let's keep going. And I'm down to 2 problems now, right? So we did 2, we did 4, we did 5. I'm going to say, really thinking in hindsight, I think 5 was probably the easiest one, and then 4, and then 2 wasn't so bad, but 2 took some time. I got through it. And what I want to do is I want to start looking at, between 1 and 3 now. And I'm going to say, I think I want to do 1. All right? They're about the same length and wording, though, aren't they? But it's a circle problem. I think I probably understand what the circles are. It's a circle, has a radius r and centered at 0, r. It's just write an equation for the locus of centers of circles, which are tangent to the circle and the x-axis. What type of curve is this locus? Well, if I don't understand that, I probably couldn't do it, right? Now, I always say if I don't understand something, I want to read through it. I'm gonna cut to the chase because I give you pretty good graphics in these notes here. So I want to go to that, and I want to talk about the graphics of it. All right, with my eraser, I guess I was writing on this before. And I want to just tell you that I kind of read the story, and in my mind I'm visualizing a picture sort of like this. Now your picture might look a little different than mine, but I got to start putting down points over here. And I know this point over here is going to be, the x going to be 0. They said this big circle centered at 0r, right? And what I want to claim is I know that this over here is the radius of the circle, all right? Now, this one over here, and this is really what they were saying about something about this x thing as being some points over here. So I'm going to describe this as a point, and the point I'm going to describe it as x, comma, y. And once I do that, I want to claim over here that if that's true, the radius of this circle is going to be y. I hope that's obvious to you. So what's the distance over here? It's y. So what's this total distance? And I want to make sure you understand what I mean by that. This total distance here is r plus y. And all I'm doing is a picture at this point. It's all I'm doing. Now, next thing I want to do is I want to figure out, I know this whole thing over here is r. It's still the radius. But then I just want to get this triangle done. And I'm going to talk about this distance over here. And what would that be? It would actually be r minus this guy's distance. And what's that guy's distance? Y. All right? Wow, I get another problem, don't I? I have to figure out, and again, I figured out this distance. Let me get my little red, not red, but I want to do this guy over here. And what's this guy's distance going to be here? And someone says, why are you doing that? I know a relationship for that right triangle. Now, it's nice to have a picture, by the way. And that would be what? And that would just be x, wouldn't it? So I'm going to use the Pythagorean Theorem. Let's write this down for you. So it's going to be r plus y squared equals, it's going to be the leg squared. This is a right triangle, by the way. It's going to be r minus y squared plus x squared. Now, by the way, you may be totally lost at this point, but I'm saying if you're lost, just keep moving forward. You're going to see something recognizable at some point. But right now, I don't see anything recognizable, but I'll just keep moving forward. What do you get? R squared plus 2r y plus y squared. Again, I'm just moving forward. Hope I see something eventually. R squared minus 2r y plus y squared plus x squared. I'm still not seeing anything. So I want to keep moving forward. And I want to be honest with you, I do notice some nice things over here. I notice I could subtract r squared from both sides, and that disappears, and subtract y squared from both sides, and that disappeared. I could also add 2ry to both sides. I'll write that down for you. And the whole point is to simplify things. And so what would you get there? Well, you would get 4ry on the left side. And we get on the right side, you get x squared. Now, this is where I start to recognize what this thing is. And again, we're talking about the points. These things over here, that's what they were talking about. And they said this forms some kind of picture, and it does. And what's a picture? A parabola. That's what it forms, a parabola. All right, what I'm going to do is I'm just going to go over here to the notes and see if it answered the question. And the question is, what type of curve is this? I told you it's a parabola. It's a parabola. Now, of course, they put the work down. They got the picture down. They gave you some additional information. They told you about the vertex. They told you about the focus of that parabola as well. All right? So I also provide, I'm not going to say it's going to be helpful to you. It may not be helpful. I think this was a helpful picture. I think this was helpful. Right? You might struggle with that picture yourself. I like to draw accurate pictures, by the way. But I'll be honest with you, I have a tough time drawing accurate pictures. I'll be honest with you. That's why I use a machine to do it. The other picture they provide for you, which may seem really bizarre, is this parabola right over here, which depends on r. And I used a computer to generate that image, by the way. I see the parabola. It's in blue. All right? And then I see that, the circles being drawn over there that are tangent to a circle whose radiuses are. That's all that is. All right? Again, this may not be informative to you. You may look at it and say, I don't know what that tells me. Okay, so I'm going to say over there, that was probably the most difficult thing about that one is to visualize what they asked for. Right? And I did that for you. All right, I did that with that picture. I'm hoping that's helpful to you. But again, if you're doing, chicken scratch work, the chicken scratch may not look very good. I mean, it just doesn't look good. You can't get it. All right. So I'm going to say that was helpful. And we got one last problem to do, right? We did 2, and I'm on to problem number 3 now. So I'm going to talk about it, and as I read through it, I'm going to be drawing my chicken scratch down, and it's talking about point A and B are 100 feet apart. Point A is 20 feet above the x-axis. So I'm going to try to draw a picture of what something looks 20 above the x-axis, and I'm going to make it simple. I'm going to put it right here. I'm going to tell you this point over here is going to be 0, 20, and this is point A. And then they say, point B is 60 feet above the x-axis. So I'm going to put this over here and say this is 60 feet above. I just don't know what the x is at this point. So I'm going to say it's 60. And then what they said the distance between those 2 points is 100. All right. You know what? I don't know what this is. I'm going to call it x. And what I'm going to do is I'm going to say that it's kind of a simple formula for that. But I got to figure that out. Let me write this down for you. So what's it going to be? 100 squared equal, let's take a look at this. This is a distance formula, right? So x minus 0 squared, that's going to be x squared, plus 60 minus 20 quantity squared. I think I can do that. That'll be 10,000 x squared. Well, 60 minus 20 is 40, and 40 squared is 1,600. Well, x squared. But I want to point out, looking at my picture, x is greater than 0. All right? I'm just looking at my picture. So that's going to be 8,400 now. And I'd like to figure out what x is. That's the square root. I know it's not plus or minus, by the way. I have no objection to writing that down, but I'm going to write a little differently. I'm going to write 8,400 as 100 times 84. So when it says, why would you do that? I'm looking for perfect squares, and 100 is a perfect square. And then 100 times 4 times 21. The square root of 100 is 10. The square root of 4 is 2. That's going to be 20. Root 21 is equal to x. I'm going to get my eraser out. I'm going to erase this now, and I know what the point is. The point over here is 20 root 21 minus 60. All right? Take a moment to digest that. And as you do this, again, I'm going to erase things because I think that's not their question. All right? So someone said, why'd you get the point then? I don't know. I guess because I could. Maybe it'll be helpful. Who knows? All right? So I think I did it right. Let me erase this business over here. All right? All that little, baby work. Maybe it's not baby work. Just simple algebra. It really was. Erase this over here. Erase this over here. I'm going to erase this over here now, too. So I think I got a picture. This is B over here. What's the question, though? What's the shortest distance from A to B? Well, I ended there. The shortest distance from A to B is 100. The straight line distance. But they didn't say that. They said if you must touch the x-axis. So I hope you realize that touching the x-axis means I'm touching it. So that means I got to come down here and then go back up. All right? So I don't know what that point is, though. So I'm going to simply say it's x. I have no idea. 0. Now, I think you have some intuition about this. I think you know the x has to be greater than or equal to 0. Right? And it has to be less than or equal to 20 root 21. All right, but now I got trouble. The trouble is writing down a function to minimize. I'm going to do this by calculus, and you may have better ways of doing it. I'm not saying otherwise. But what I want to do is write down the distance. that I have to travel. So the distance is going to be equal to a root problem. Let's do the first distance. And I want to point out what I mean by that. We're doing this one over here. I'll write that down for you. What's that going to be? It's tough. I'm not saying it's easy, but remember, you're in a competitive exam. This is the last question. If you run out of time, at least you have something written down where they're looking at this work and say, gee, they've got close. They just ran out of time. All right, what do you get over here? Let's write this down. So it's going to be x squared. You may wonder, it's kind of looking at this point and this point. I'm just doing, 0 minus x when you square it, you get x squared. Let's see, plus 20 minus 0 squared. That's going to be 400. Plus, you got to do the other distance now. Let's get this distance over here. And what do you do over there? Let's put this down. So it's going to be a root problem again. All right. So let's see. It's going to be 20 root 21 minus x quantity squared. Let's see, plus 60 minus 0 quantity squared. So that's going to be what? 3,600. All right? And someone said, what are you going to do now? Well, this is the part I really don't enjoy doing, but this is a function of x. And the function of x is this thing right over here. So what I want to do is I want to kind of talk through it now. All right, I just want to talk through it. I have it written down nice and neat. I want to do a chicken scratch here. So I wrote this down for you. All right. So it's really the same thing. I mean, I didn't square it out, but you get the idea. All right. Now, I want to minimize this, right? So how would you do that? I simply say it's a function of x, and then I take the derivative. And let me go through that with you. So the derivative first, guys, really not that bad. If I'm looking at it, it's a square root, so it's like a half power. So I'm going to say this derivative is fairly easy to do. Let me repeat what I mean by that. This would be 20 squared plus x squared to the 1/2. And if you were to take that guy's derivative, it would be 1/2 20 plus x squared to the minus 1/2 times 2x. And that simplifies pretty nicely. And why is that? The 2's cancel off, and left with x over the root of 20 plus x squared. So I'm hoping that's not difficult to do. I hope you see that there. All right? Let me just erase this. I'm kind of done with that. And I want to do the next one. And the next one, it's really kind of similar. All right? Basically just the derivative. It's a really kind of hairy looking problem. And, I kind of just took the derivative of that. And it's, 1 over 2 times the root. And then the top as the 2 comes down. It looks pretty easy. But you get a minus 1 there. All right? That's why I have this minus sign over here. All right? Let me get the eraser out. Here comes my big problem. My big problem is like, how could I possibly get the critical number there? And I got to inform you, the critical number C has to be somewhere between the 0 and 20 root 21. I'm hoping to find some number over here that I can start to work. All right, so what do? I set the derivative equal to 0. That's written right over here for you. And I look at it. I look at this over here, and I realize that for this to be equal to 0 means that this guy here must equal this guy over here. And that's all I wrote down. I said this guy here must equal this guy over here for that to be 0. All right? So I kind of worked through that, and I want to point out looks like what I did was I squared both sides. All right? Again, this is just me talking through the work that I've typed up for you. Let me get my eraser out now. Again, I'm still looking for that critical number. So it looks like I squared both sides. And if I do that, I get this over here. All right? The next thing I did, right, looking at that, it looks like I was trying to simplify it. And by the way, you may say, I wouldn't have done that. I would have done something different. We're not saying you shouldn't have done something different. I'm just saying what I did. And you may want to pay attention to that. You may not want to pay attention to that. It's up to you. It looks like what I did for this term here is I divided through by x squared. All right, now that may be a little dangerous, but the bottom line is I'm looking for that critical number. All right, So I'm going to say I would get this over here if I divided that top by x squared and the bottom by x squared. Relatively simple. And next thing was that I divided the top by this and the bottom by that. And what would you get? You would get 1. Then you would get what? You would get 1 here. And then you get 60 squared, right? Because I'm dividing 60 squared by that number. That's not so bad. I did that. But again, you may say, I wouldn't have done that. We're not saying you would have done that. I'm just saying this is what I did. And I'm explaining what I've done. Then what I did is I took the reciprocals of both sides. All right? Took the reciprocal of both sides. And why is that? It's easier for me to do that because it looks awful otherwise. And I took the reciprocal of both sides. And what I get, this would equal this over here. And then what do? It looks like I subtracted 1 from both sides. And I get this over here. And I'm starting to think to myself is, things sure are looking a lot easier to me. All right? And again, I want to point out, I'm looking at my critical number, and I know it's somewhere over here. All right? Yeah, it's just, you might say it's intuition. Maybe it is intuition. Here's the deal. You take the square root of both sides. Don't have to worry about plus or minus, by the way. And what do you get? Well, the square root, again, positive numbers, 20 over root x. This guy also, I see a square root problem. And now I got a problem over here. I have to multiply it out, right? Clear the fraction. And again, I know the cross multiplication is a bad word in mathematics, but to me it's not bad. It'd be 400 root 21 minus 20x equals 60x. That would be 80x, 400 root 21. Then I would divide by 80. You get x equals, well, 80 goes into 400 5 times, 5 root 21. This is my only critical value. My only critical value. This is a critical value. Is that on that interval? It sure is. So 5 root 21 is definitely an interval. All right? What do I have to do now? This is a problem. I realize that. I'm using what's called the closed interval method. It's overkill, though. I'll be honest with you. And I realize it's difficult, but you plug in f as 0. This is an endpoint. This is why they call it a closed interval method. You'd get this number over here if you did that. I'm not going to go through that with you. You can do that yourself. I do the endpoint. When you do the endpoint, you get this number over here. And I do that, the only critical value in that would be this one over here. And if you do the arithmetic, you get this one over here. And again, this may be overkill for you. I'll tell you another way of doing it, by the way. And looking at it, what's the minimum value there? The minimum value, just looking at it, I know it's tough to look at. I know I approximate these things over here. It is tough to look at. This is the minimum right over there. So that's the point we're looking for. So let's go back and make sure we've answered the question. And what's the question going to be? The question is, what is the shortest distance from point A to point B if you must touch the x-axis? And right now I know it. This is the shortest distance right over here. So the shortest distance is 20 root 37. Let me show you another way of doing this. And the way to do that is there's only one critical number in this whole interval, and that's going to be 5 root 21. And what I do is this is a derivative. And I need to take a point that's after that. So I'm going to say, like, if I were thinking of a point after that, I'd pick like a billion or a trillion, whatever, and I plug it into the derivative. Now I want to point out, looking at the derivative, I know it's tough, by the way, but this is the derivative over here. I hope you realize if you plugged in like a billion, all right, what kind of number would you get? Well, looking at it, this term would be positive. And if you look at this one over here, a billion, and I'm doing the subtraction, it's going to be plus plus. What do I know about this thing? The derivative is positive, which means the function's increasing there. All right? Now, I pick another test value over here, and any test value would do. I'd probably pick 0. As a test. By the way, I picked a billion over here, if you remember. That's certainly after 5 root 21. That's a big number. 0 is pretty simple, though, right? What do you get over there? 0 minus, well, if you looked at it, if I picked a 0 here, The second term would be 20 root 21 over some finite number here. Clearly negative. Put this over here. What does this mean? This is minimum. So no, you would not have to use a closed interval method or any kind of evaluation. What's the problem though? I gotta be honest with you, if this was a competitive exam, I probably would not do the arithmetic. I would just simply say the distance was this thing over here is f evaluated at that number, the critical number, 5 root 21. This was by far, in my opinion, the most difficult question on the exam, all right? And it took some time to get through it, all right? A lot of algebra and things like that. Have we answered all the questions, though? Let's go through it, make sure we've done that. I've done this. I've done this. I've done all 5 questions. Now, granted, it's tough, though. I don't think you have to answer every question for the exam. But the problem is with this, and I hate to say this, there is discrimination on the presentation. And certainly, I wish I could type things up. People would judge my work better if I could type it up. But the bottom line is, you got to get things that look nice and neat. They're not going to be straggling through bad work to try to give you points. They're looking for the best looking answers. And it's really kind of easy to look through a stack of exams and see who has the best work and the most clear answers written down, all right? And be aware of that, all right? And again, if you have questions, please feel free to reach out to me. My name is Bannon, and my email address is b as in boy, the @ symbol, NNON.US. Thank you for paying attention.